So, first, apologies for my tardiness. Today is not a good day for me, but let's skip it for later. Apologies, you had to wait. Usually, developers see their application as a shiny racing car, kind of Ferrari. And more often than not, at least in places I worked in, they have some basis for it. So they have high test coverage, they have actually made a number of steps to verify that the application works as it is supposed to. They use source control systems, SonarQube, tools like that. So generally, they do a good job. Of course, they expect that the racing car will have like racing infrastructure. And usually, what they get is kind of different. It may be for a number of reasons. Perhaps they do not know that we on the DevOps side are actually on a constrained budget. We really can't afford anything more than that. Perhaps previous applications that they actually delivered were kind of off-road applications, so we prepared off-road infrastructure. Perhaps it was a simple misunderstanding, the copy-paste of a wrong specification file, whatever. The end result is that the user experience is as pleasant as any of the two allows. And if infrastructure allows only for a bumpy ride, then bumpy ride the user's gonna get. So infrastructure equals application. They are both equally important. If you test one, test the other. And DevOps should be decision makers for the apps, like from the very get-go, from the inception stage of the application. Observe, measure, and tune the infrastructure for the application needs. My name is Tomek. Usually at this moment, Jacek actually starts speaking with me. Today, Jacek is ill with a rather high fever, and unfortunately, he can't attend. So he sends his regards, and he asks you to use green voting buttons. So I'll try to tell you today what to teach developers, how to teach them, what to tell your DevOps if you're on the developer side, what to know about infrastructure that actually might influence your decision, your coding decision, and this will all be based from my experience, from various consulting gigs and other things like that. So, when you ask what to look at, the obvious answer is monitoring. So, hands up, who used one of the tools outlined on the screen? I like you guys. You're the good audience. So, whoever actually had a case when he used two of the tools at the same time? Much fewer hands, as expected. Now, who had a case when actually his application was being monitored by all those tools on the screen? And that's a very good response. I like that you actually stay motionless here, almost. So, if you ever are in doubt about your monitoring tools, from my experience I can tell you this: avoid Nimsoft. I've put a little dev skull to it for a reason. It's actually a tool that's been known to hurt me on more than one occasion. It ate 90% of CPU time, it provided bollocks metrics, and it made a number of other hog resourcing moves. So avoid it. Well, the problem with, of course, never too much monitoring is that, as one might know since 2007, there was a study done on Amazon. And it turns out that if you increase the load time of an average page on Amazon by 100 milliseconds, you go 1% down in sales. Well, often people take monitoring as some sort of black box. It's magic. It works, but I don't know how, I don't want to get into how, I don't want really to know more. And in fact, there are two sources of stats for monitoring: drivers and kernel. And there's a number of commands that you can actually use to create your own monitoring. Perhaps you're not allowed to send your data to a cloud. So most of the monitoring application ready out of the box, like say AppDynamics, New Relic, things like that, they are actually forbidden. So then you may want to actually take a look at number of utilities, perf utilities, that Linux actually gives you out of the box. Of course, when we are actually talking about what to look at, and we're on the monitoring side, I'd like to tell you one very simple metric that Kirk, Pepperdine, and Heinz Kabutz, hands up, who knows those people? Okay, and Milan is busy checking his phone because I know that he at least know one of them. So, guys, actually, those are people who work in performance and training business. They have 10 or more years of experience, and most often than not, they are called upon to diagnose some sort of problems, usually related to performance. So they have this methodology to approach such problems, and they call it the box. So what is the box? The box actually tells you that you need to go top to bottom. When something strange happens, you first take a look at what is actually going on. So who uses my application, who uses my system, and how they use it. Do I have some sort of integration that I know that can actually drive my traffic like 300% in like 2 minutes? Perhaps my clients have some sort of promotion day. It happened to me. All of a sudden, application went crashing down, burned totally, everything is red, and what the heck is going on? It turned out one of our clients had an advertisement day, and they invited everybody to come and use their services, which we're totally not prepared for. Yeah, this is crucial in a number of ways. So first of all, take a look at how the application is used. When do you have traffic spikes? When can you expect traffic spikes? What will happen if all of a sudden you get added a new customer? New customer for you means 1 user, or 100 users, or perhaps 6,000 users. With my recent company, I never could tell. It could be like one new company could bring like 6 users total, out of which 2 would ever log into the application, or it would bring like 6,000 users, and most of them would bring log into to the application. Or, for example, we had made a contract with Chinese Bureau of Work, and Chinese Bureau of Work had actually this plan, which is government enforced. Every single Chinese student needs to have an account. And that means a lot of accounts. So, first of all, take a look at the traffic, take a look at how your application is used, and graph it. Monitor actually how it's used, not only in terms of traffic, like incoming connections or whatnot. Monitor it also in terms of what are your business transactions, kind of like New Relic does. Then, if this doesn't answer the question to what is causing my recent problem, go one level lower. Bring in developers and start thinking about how the application actually behaves, whether it's some sort of kinky algorithm that should be redesigned long ago, data structure that's not really concurrent or whatnot. Then go lower, JVM, or if your application doesn't use it, go straight for the hardware. Sorry, operating system, then hardware. Of course, some of you might plug in virtualization somewhere along there. The problem with growth of your application is that usually on this level, when you have the flag, the problems start to appear. But they are really, really noticeable when people start asking questions. And usually by then, a number of things happen, and it's really hard to diagnose what really caused the problem. Also, when the diagnosis of the problem gets handed to developers, they tend to look at what they do most, at the code. And there is a number of cases when they spend like 6 months putting hard work in and optimizing some sort of code which they always suspected was really faulty. And it turns out that perhaps it was. But overall, in the grand scheme of things, it's like 1%. Too bad. Of course, with new monitoring tools, there is a number of problems that can happen. For example, with Java Melody here on the screen, I had a case where RRD, round-robin database, was not really RRD, but something almost like RRD, which caused it to grow when I didn't expect it, and which caused my hosting to actually kill it because, well, it grew way too much. So take a look at overhead that your monitoring tools introduce, take a look at how much space they need for their logs, and what is introduced in new versions. Java Melody, however, with all that, I still recommend for pretty much every DevOps because it allows your developer to gain insight into what happens on production. So he can see that after deploying this new code, all of a sudden, entire usage of the application shifts in another direction, that perhaps he forgot something and suddenly there is a lot of 404s, things like that. So disaster sooner or later is bound to strike, and then it's the question of backups. Now, I had a very interesting conversation once when I phoned our internal IT department and I asked them, well, we have this artifact server called Nexus and just wanted to know, it is backed, right? Of course, Tomek, of course it is backup. Now, who do you take us for? Oh, cool, sorry for asking this question. So, how it's backup actually? Well, it's backup by daily backup, so delta backup. Okay, that's cool. So we have like first backup and then deltas, and every now and then we have full backup, right? Well, no, we have only first full backup, then we have only deltas. Okay, and how long are they kept? 6 months. Are you certain that these are the settings? Because you know the system is lifelike for 2 years. We'll call you back once we check it. They never did. So no matter what side are you on, DevOps or hosting or developers, pay attention to details in the backup, and if the backup has not been tested, that's not a backup. For high availability primer, if you want more concepts, this is very good source. Maciek Lassek's presentation. I think Maciek is on the conference, so you may actually try to grab him in the hall. Usually, the disaster recovery plan looks like this Dilbert comic. However, recently things have been changing for better. Actually, a few years ago and now, when I compare the results of this survey, would have looked quite different. A number of people still do not use actually backups or do not test it. They do not know whether it works or not, but a number of people already does. And some even do recognize what is RTO and RPO. Now, do I need to explain this or do I skip it? Hands up who says skip it. At least 5 hands, 7, 1/3 of the room. So quick explanation for the others. When something happens, the problem is when it happened on your backup timeline stage, axis, sorry. So if I have backup timeline, and here is where I start backup, here is when it finishes, here is when I make all the checks, here is when I load it to other media. Then I actually wait for the van arrives, I pick it, I actually toss it to the van people catch it, and they drive away to store it offline. So when they arrive at the offline place, there are some checks, like for example, whether backup was taken correctly and all that. Now, problem is where on this scale, when on this axis actually incident happened. So do I have the backup, or do I think I have the backup, but it hasn't been yet tested? Or is it just en route to offline destination or other things like that? Depending on where the incident happens, you can actually tell how much time you have till you recovered everything and how much data will you lose while you are recovering. So using the metaphor with driving, when I'm driving, RTO is, I think I'll reach my destination within X hours. And RPO is, I think I covered like this and that kilometers and I will lose this and that data. So that is RTO and RPO. They are very useful when you are actually discussing SLAs. 2 notes on backup: snapshots, VM snapshots or other snapshots, that ain't backup. And replication, like you replicated the data, that ain't backup either. So in the server room, there is a number of devices, and hands up who can say what these devices are? Most of the people, nice. So we have access points, we have firewalls, we have databases, we have switches, we have blades, and various other devices. They all have parameters. Those parameters are, and that is very important, finite. You cannot expect that they will scale till like forever. They are finite and they end at some point. And with that in mind, say that you have a very nice boss who said, unlimited budget, design me a server room. The only problem is server room is really small. So you of course go to buy the best of the best. So say this was a few years ago the top and you can actually allow it, so you go for it. There is 4.8 gigabytes per second of capacity in the switching and 24 ports with full duplex. So this means like 200 megabits per second per port, which is not a bad number. At least a few years ago it was quite a good number. The problem with switches are that usually the technical specifications are kind of like advertisements. So they say we are achieving like this 200 megabits per second per port, which is quite a nice number, but probably only on TCP. Usually the specs give you like TCP, sometimes they also give you UDP numbers. So handle actually waiting, what traffic will you have? Will you have like a lot of huge packages like on the large vehicle screen, or will you have the usual traffic, which is the huge number of small packages, when actually your switch may behave much, much worse than it is supposed to behave? So how many packets, average frame times, package traffic kind, that depends. Now here we have like number of VLANs. For example, this is one VLAN, this is another VLAN, and this is another VLAN. So pretty much you can see that we will traverse the firewall number of cases. The firewall protects us from pretty much every incoming traffic. And the firewall looks also quite good. At least a few years ago that was really quite good. It has 4.5 million concurrent connections, which is kind of impressive. But on the other hand, you can see that it has like 90K connections per second. This means actually that it actively supports 19K connections. So active connections at the moment, you have only 19K, not 3.5 million. With that, we can see that the firewall will be used very often. Again, never too much firewall. So never too much firewall user traverses the firewall, goes to the application server, then the application server sees, for that request, I need to actually pull out data from database. So it goes through firewall to database, back to firewall, back to application server. Now, finally, we can start processing that unfortunate user's request. And we offer him some answers, which of course need to pass through firewall. So who has set up like that or had set up like that? Okay, so usually when I meet such setup, I hear reasons like this is company standard. This is for safety. There are ISO norms. We will be audited, and the audit must actually show that our DB is protected, blah, blah, blah. The real reason often is thoughtlessness or outright stupidity, because when someone calls this defense in depth, hands up who knows the defense in depth concept? So defense in depth is when you actually have, it stems from ancient Greeks and their military doctrine. So they had like phalanx, and phalanx was covered by independent units of archers. And with that, they could actually throw their hoplites forward, and if someone came on it, the archers provided covers. If, for example, sudden raid of the enemy cavalry wiped out one unit of archers, there was the other one because they were like independent. And in such setup, you're not really having anything independent. If I know one exploit on your firewall, then I probably can use it to traverse it as many times as I want. Probably. Perhaps you have some weird config. Again, your firewall throughput is 19K per second. That's not really so much now, with 4 traverses per one request. So if you want real defense in depth, use, for example, vendor solutions. Pretty much every DB vendor has their own firewall tuned to the DB, or you can actually use things like IP tables. They do work. Sharing. Sharing is caring. Pretty much everybody wants to be a gummy bear. You may share pretty much everything. Network, storage, file system, virtualization, obvious candidates. You may share between number of things. Perhaps your sales wanted a pre-sale environment. So you have a box on your production which shares everything with everything else, but it's only for pre-sales demos. Perhaps the pre-production system is put in the same data center to actually have it same or not so different from the actual production system. Perhaps there are internal systems which are located there as well. So as you can see, there is a number of things you may share and between which you may share. I mentioned virtualization, so let's take a look at our server, and this actually plays some role within it. So we have 1960 drives, 128 gigabytes, and the server, the Blade server, is actually rather good. 40 cores, hyper-threading. Now, we use VMware as ex-VMware, and how many VMs we shall have? A number of people, like even in 2012, would tell you the more, the better. Never too much VMs. So VMware is really popular, and that is why it's outlined here in the presentation, because of its nice graphical user interface. It's easy to migrate, and it promises you easy backups via snapshots, which we already know ain't so true. Now, if the virtual machine actually has like 160 virtual CPUs on those settings I said, the 1960 drives and all that, and we have CPU on 30 threads with hyper-threading, then let's take it the vSphere Center or whatever you guys use to monitor this, and it shows you that the load is less than 40% per VM. Quite okay. RAM, 50% of my RAM is free. So, easy conclusion. Nothing's going on, right? I can add like another number of VMs. The same as I have. It's like, or perhaps slightly less than I have because like 50% RAM is free and load is 40, then it will leave you plenty of margins, right? How do you think? Ah, you sense a trap. Well, Admiral Akbar would have been proud of you. It's a trap, because if you take a look at physical hosts in such a situation, you may actually notice that you have very high system load and very low user load. Like, your users never reach more than 60% of your capacities. However, your system load is consistently at 20%. So 1/5 of your resources is actually being busy, doing something, and that's not the user something related. So the problem is that you're most likely context switching. When you're actually doing the work on the physical threads, they must be taken away from one virtual CPU and given to another, and so, and so, and so. Add into the fact the Robin Hood for the poor, also called vMotion. Whoever used vMotion? So vMotion is this very nice behind-the-scenes mechanism which actually steals resources from the rich VM and gives them to the poor VM, which is totally cool idea, and it takes a load off your shoulders, unless it starts running in circles. Because every time it takes resources, it will also take resources, because it must actually take a look at VM, find out, oh, too much, too little, pass the resources, and then this, of course, also eats your CPU, network, and all the other things. So I had cases where actually turning off vMotion was very sensible and good approach. There are other alternatives to VMware, but we'll not cover them much. There are, of course, things like Docker, and please do tell your developers how nice it is. The most intelligent case of actually telling a developer how he can use Docker was actually showing him that anything you would install will not break your IDE if you install it in Docker. And that was actually quite cool and really well accepted. Docker, of course, comes with sharing the libraries because it's light virtualization. And on to problems, because you will have problems. For example, perhaps you're a developer who can't even touch your infrastructure. Perhaps you're a hosting person who has to create a ticket because your environment is managed. So there is a third party which actually has all the accesses to your environment, and you create the tickets to the third party, and they do the actual work. So if that's the case, give your developers some access. Perhaps publish logs using ELK, Elasticsearch Logs/Kibana. Have them take a look at it. Have them be able to actually browse the environment in like read-only setting. Make number of steps so that they will have tools to actually diagnose problems on production in an easy for you manner and controlled for you manner. That's if you're a DevOps. If you're a developer, work with your platform team or this other third party and use the SLA. Tell them that you demand this and that level of service. Tell them actually that you need your application to be able to serve like this and that number of concurrent connections. Whatever you desire, it must be incorporated. To both sides actually use the same repository for build or deploy scripts, because this is something that is your common ground. Be you a developer, be you a DevOps person, be you anybody like on the configuration management side, you will still need the same repository for all those scripts. And you need to see all the other changes that are happening. So if, for example, the production guys need to deploy a hotfix which will actually kill all the logging for a moment, you need to be aware of it. The bell curve is the usual distribution, the so-called normal distribution. The reason I actually put it here is because of some pretty common misconception. So the bell curve is supposed to be the normal distribution, and it has like very nice outline of how much standard deviations you can have and where pretty much things will land. And that's all cool if you're measuring things like, for example, IQ score distribution across populace or other things like that. But when you actually start to take a look at latencies, response times and things like that, normal distribution very often does not apply. If you want to know more, I actually encourage you to see the presentation Measure to Fail by Tomek Kowalczewski. And in a nutshell, an average problem, so if you measure the average, it's this. Average is green, so this is your average. But there are percentiles, and for example, 50th percentile, I will not for now go into details because I don't have time what percentile is, but 50 percentiles looks like slightly better than the average. And the red line means that 1 in 10 users actually see your application like that. So when you're actually saying that average looks nice, etc., you're most likely showing off to management. That's pretty much it. What measuring the average really is. If it comes to responses, traffic and all that, just take a look at what you need for your application and measure the percentile. It's much better. So there is a number of things that I'd like you to remember, and I can say for Jacek that he would like you to remember too. And that would be, DevOps start taking part in the software creation process from the moment the application is actually designed, because infrastructure and application is one. There is no difference, at least not for the user. You need to test your infrastructure regularly, and you need to monitor the application on production business-wise. Actually have some sort of monitoring that will tell you that the application is performing as users would expect it to. Perhaps monitor the SLA path, perhaps monitor the critical path, perhaps something else. Learn, as a DevOps, learn common operations that your apps actually do, so that you would not be surprised and you would not be clueless when it comes to actually diagnosing some problems. Teach developers infrastructure, or if you are a developer, learn your infrastructure, learn it by heart. Take a look at logs, pester your DevOps that they will give you access to the logs, that you will be able, for example, to have a machine which will pull the logs, index them, Elasticsearch, Solar, whatever comes to mind. Have common repository for scripts that relate to how your application is built. The build process is the common ground where everybody meets. So make sure that it is actually co-designed, co-developed, and co-maintained. Craft SLA for the application together. It's actually very cool with the design of the server room that I showed you earlier, that we had like large appliances which could do a lot. But number one error with this design was that we never asked what application will run there, or what applications will run there. So we designed server room for like something, perhaps. So hardware specifications can be clever advertisements, and sharing anything doesn't add resources. Scratch average, use percentiles, and that's pretty much everything I have. Thank you.
Any question?
One short question. How do you,
What do you use to monitor dispenser percentiles? How do you set up your monitoring to display this? Because usually you like things like, I don't know, normal monitoring gives you the average and that's all.
In the worst case, I just use some maths. Like, for example, few lines of whatever code which actually give me the percentile I want. Because sometimes it's okay to like monitor like 16 percentile, sometimes I want to actually go for maximum, so 99 percentile. It really depends on what I'm seeing. With the highest percentile, there is need for some maths, so usually the tool I would actually take a look at would be also HDR histogram, which is by Guillotine. And for most Java code and benchmarks on that side, it does the work really well. Because it deals with coordinated omission problem. A number of tools already actually offer the capability out of the box to like monitor the percentiles. Most likely, pretty much everything that Netflix let loose on the world does that. I believe New Relic, when I actually reviewed this last time, also had that capability, but I might be wrong.
Okay, thank you.
Thank you very much.
Thank you for the question.